students, this is Mr. Bornheimer, and I'm coming to you tonight just because I've recorded some videos for you to watch, and I hope that you'll find them very useful. As always, when you have video lessons and I'm not there to actually teach you, I want you guys to, you can pause them, you can look at them, they're hosted on YouTube, you can watch them over and over again, but things that I do expect. First of all, that because they are video notes, they might not be as dynamic or exciting, and I apologize for that. However, they're still really important. So you need to take notes on them. Okay, so I will be expecting to see, or if I ask to see notes on the lessons that I've taught, I expect you to be able to provide those notes for me. Secondly, you should be able to use these videos to your advantage. I won't be reteaching these lessons in class. So if you, for whatever reason, didn't get the material, you need to go back on YouTube either at home or during study hall and watch the videos over again. Thirdly, please be mindful and respectful of those around you, because as always, videos can be distracting. You might be able to zip through the video and understand everything fine, but not everybody might understand everything exactly the same way you do. Okay? So, and some people might not get it right away and need to rewind. So please be respectful of where people are at and what people are doing as they kind of watch these videos and prepare to take notes and things like that. All right, so I'll be back as soon as I can. Otherwise, enjoy the video notes, and I hope you all have a wonderful day. Thanks for watching. Hello, students. This is Mr. Bornheimer. This is Math 7's Lesson 2-5 concerning mixed numbers and improper fractions. Okay, here we go. Let's start with what an improper fraction and mixed number really are. Okay, so let's start with an improper fraction. Okay, a typical fraction has two parts, a numerator and a denominator. So let's go ahead and take a look here. Let's start with our numerator. Okay, so the numerator, let's just look at 1/2. Okay, the numerator and denominator. Okay, and if there's some misspellings there, I apologize. The numerator is the number on top. And typically speaking, in a normal fraction, it is the smaller number. Okay, then you have the denominator. The denominator is the one on the bottom. I usually like to remember this by thinking denominator down and down, 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 down below. So the denominator down. Okay, so we have the numerator on top, the denominator on the bottom. And we can see that emphasized here with our 1 on the top and our 2 on the bottom. Okay, now an improper fraction, very similar, okay, except that it looks something like this. Let me go ahead and add a thicker pen here. And an improper fraction has a larger number on top. So an example of this would be like 4/3. Okay, 4/3 is still a fraction, but it's an improper fraction. It has a larger number on top and a smaller number in the bottom. It has a larger number in the numerator, and it has a smaller number in the denominator, down, 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 down below. All right, so this is what we call an improper fraction. Now, typically speaking, there are useful ways in mathematics to utilize this format for fractions, especially when we're trying to find what is called a common denominator, where we want our denominators to be the same. Okay, and so we're going to take a look at some of those things. Now, other examples of this include, and I'll just give you a couple more examples of improper fractions. Okay, these would be examples of improper fractions. 3/2, 5/3, 700/4. Okay, these are examples of improper fractions where the numerator the number in top, there, and there, is larger than the number in the bottom, okay? So here, here, and here, okay? So these are improper fractions. Now, let's go ahead and take a look at what an improper fraction looks like when it is a mixed number, okay? So let's actually let's focus on this example of 5/3. We're going to focus on this example right here. All right, 5/3. Well, I want you to think about 5/3 in a different way, okay? We know that 5/3 means that really we are dealing with something that's equivalent to 1/3 plus 1/3 plus 1/3 plus 1/3 plus 1/3. Okay? Really, we're dealing with 5 1/3s, or 5/3. Okay? Now, I want you to take and focus your attention in on the first 3 of these. Okay? 1/3 plus 1/3 plus 1/3. Well, that's really 3/3. Okay? Well, 3/3, that's the same thing as 1. Interesting. And now we're left with these 2 1/3s, or 2/3 left over if we were to add them. So we go ahead and say, well, that's the same thing as 2/3. So really what we're doing is we're adding 1 plus 2/3, and that gives us the mixed number of 1 and 2/3. Okay? So that's how we get a mixed number from an improper fraction. We went from this here, okay, down to this here, and they really are the exact same thing. They are the exact same thing. Okay, let's look at 5/3 in a different way. It's kind of like the shortcut. All right, so here we go. 5/3, if we look at this one more time, well, really when you're working through this, you kind of have a dialogue or a conversation in your head, okay? And so what we say, okay, 3 goes into 5 one time, okay? So I can write down 1. And then I ask myself, well, how much is left over if 3 goes into 5? Well, in my head, what I'm doing is I'm saying, well, that's 5 minus 3. Well, that leaves me 2. So whatever's left over on top or in the numerator gets added to my mixed number with the original denominator. Okay, so really what's happening is I'm saying the numerator here minus the denominator. Okay, so that's what's going on right here. And whatever is left over, this 2, gets carried over to the top of the new number here. So let's look at a couple more examples of this just to kind of clarify it. Okay, here we go. This is 4/3. And we're going to look at the example of 7/5. Okay, we know if we're looking here at this, that 3 goes into 4 one time. So I'm going to go ahead and just say, okay, well, this right here is the equivalent of 1. Now in my head, what I'm going to do is I'm going to go ahead and subtract 3 from 4. Okay, because I know what's really happening is I'm removing some from the whole. And I'm left with 1/3. Okay, so I know that I'm left with 1/3. Alright, so that improper fraction, 4/3, has turned into 1 1/3. If we look at 7/5, we say, okay, well, 5 goes into 7 one time. And that leaves me with a remainder of a 2. So it's really like saying 2/5. Notice again that the denominator here and here stays the same in our new mixed numbers. Okay? Let's look at an example where we don't have 1 as our first number. Okay, here we go. This is going to be, let's do this as 9 halves. Okay, this is definitely an improper fraction. My number on top is larger than my number in the bottom, or the denominator, down, 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 down. So I ask myself this question: how many times does 2 go into 9? And I kind of think to myself, 2, 4, 6, 8. Well, it goes in 4 times. So that means I have a 4 here. Okay, and then I have to ask myself, well, 2, 4, 6, 8, how much is left over to get to 9? Well, it only takes 1 more to get to 9. So I end up with a 1. And again, remember, this denominator carries over. I get a 2 here. Okay? To kind of think about this in a different way, let's go ahead and look at this in a little bit of a different way. 9 halves. Well, that's the same thing as 1 half plus 1 half plus 1 half. And I'm just going to kind of keep going here, because I've got to have 9 halves. Okay, I have 5, 6, 7, 8, 9. Okay, well, that's a lot right there. Well, let's just count them just to make sure. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9 halves is what I have right in front of me. Well, I know that every 2 halves creates 1. Okay, 1 half plus 1 half, well, that's a 1. Okay, so that's all the pairs I have. So that's going to be 1 plus 1 plus 1 plus 1 plus whatever's left over, which is a half. Look at there. Okay, 1, 2, 3, 4 plus a half. 4 halves. Okay, so that's really what we're doing when we turn improper fractions into mixed numbers. Hello students, this is Mr. Bornheimer. This is part 2 of our lesson 2-5 on mixed numbers and improper fractions. In this part, in the last part, we looked at improper fractions and their role and how we can take those improper fractions and turn them into mixed numbers. Okay, so to kind of do just a quick review here, let's go ahead and look at just one example. Okay, here's an example of an improper fraction. To change this to a mixed number, okay, we have to look at it as a whole number plus a fraction. Okay, the whole number that we're going to be looking at is really how many 3/3s can we fit into the 7/3. Okay, so again, 1/3 plus 1/3 plus 1/3, and so on and so forth until we have all of the thirds that we're looking for. Now, in reviewing this concept, it's actually going to tie perfectly in with this part or this video. And the reason I recorded it in 2 parts is so it's easy to break down and watch in case you're trying to review for a quiz or a test. So again, what we want to notice here is that 3/1/3 actually add up to 3/3 or 1. Okay, if you add 1/3 plus 1/3 plus 1/3, so 1/3 plus 1/3, 2/3, plus 1/3 is 3/3, which is 1. Okay, and we have 1 here. We add those, and then we tag on whatever's left over. So really, this all works out to being 2 1/3. Well, what we're going to do is we're going to take this idea and we're going to work it backwards. Okay, so we're going to start with the mixed number, and we're going to work it backwards. We know what the improper fraction should be, and so we can kind of work from there. So we're going to take our 2 1/3, and we're going to work it backwards like we didn't know what the improper fraction was. So let's say that you're given this problem on a homework, okay, on a homework assignment. It's a question, you have to answer it. They give you the mixed number and they say, write it as an improper fraction. The first thing I'd want you to do is I'd want you to be able to look at it and be like, okay, let's take a look at this 2 here. Okay? That 2 is a whole number. Well, to fully understand this, we have to understand that when you're adding and subtracting fractions, you have to add and subtract fractions with the same denominator. So what we should understand is that that 2 can really be written as something over 3, and that 3 comes from this right here. We really want to be able to write our whole number here as a fraction over whatever denominator we're working with. So in this particular case, you might think, well, yeah, sure, we'll write it as 3 over 3. But the problem here is that that does not equal 2. That equals 1. We're looking for something over 3 that equals 2. And so the conclusion here should be that we can actually rewrite 2 as 6 over 3. That equals 2. Okay, and we can substitute this 6 over 3 in place of the 2. So that it ends up looking something like this. 6 over 3, okay, which really equals 2, plus 1/3. Okay, notice it's the same thing. It's really, okay, it's really 2, this equals 2, and plus 1/3. 2 and 1/3. Okay, it's really the exact same thing, but we've made it work now by making it look the same. And so what we see happen here is we have 6/3 plus 1/3, which equals, and as you can probably already guess, 7/3. And we know from our previous slide that that is indeed the correct improper fraction. Okay, let's look at 1 or 2 more examples of this just so that we can get a good feeling for it. Let's start now with the mixed number 1 2/5. And your goal here is to take this mixed number, okay, that's not a hashtag, that's actually a mix that actually represents the word number, and turn it into an improper fraction. And that's not the word if, that's a kind of an abbreviation for improper fraction. Okay, so let's take this mixed number and turn it into an improper fraction. The first thing I want you to do is I want you to change the whole number right here into a fraction. And we know what kind of fraction it has to be because it's based on the denominator of our original mixed number. So 1 is kind of a simple one. 1 is really going to end up being 5 over 5. That equals 1. It's the same thing. Okay. But it's useful to us because by having the same denominator, we can now add that to that 2 over 5. So really what I've done here is I've taken this mixed number and I've turned it into this kind of example here. Now what we do is we just say 5 halves plus 2 halves. Well, that's a total of 7 halves. Or sorry, not halves. That's my bad. 5/5 plus 2/5 is really 7/5. Okay, and so we see this improper fraction come out of this. Now there is a shortcut way of doing this, though it's not, for those of you that truly understand this, you please understand that everything I've just showed you, you need to be able to explain and demonstrate for me. However, when it comes to being able to take a test or quiz in a timely manner, it's always good to have tools in our toolbox, multiple tools, so that we can work quickly and efficiently to solve problems in whatever way we feel most comfortable. So I'm going to show you kind of a shortcut method. There isn't a whole lot of mathematical logic to it, meaning that it's not something you could just reason through, but it is a tool you could use, and maybe you already use it. So let's go ahead and take a look at it. Let's say you had 1 and 7/11ths. Okay. Now I'm going to go ahead, and that's a mixed number, and we want to turn it into an improper fraction. This shortcut really only works from mixed numbers to improper fractions. And what I want you to think about is a counterclockwise arrow. Okay? And on this arrow are different stops. The first stop is multiplication, and the second stop is addition. So really what we can do is we say, okay, we take our 1 and we multiply by the 11. Oops, didn't want to go quite that far. Well, I'm going to have to erase that. There we go. I want it to be an 11 here. We multiply by 11, and then we go ahead and add whatever's on top. Okay, in this case, 7. So the way this looks as a mathematical equation would be, let me write this out for you, 1 times 11. Oh, Mr. Bornheimer keeps writing H's here. Not sure why. And I'm going to put that in parentheses so we know that needs to be done first. Plus 7. Okay? So 1 times 11 is 11. Plus 7 is 18. So you take whatever that sum is for this equation here, and you put it over the original denominator, which is 11. So the answer should be 18 over 11, and that would be the improper fraction. We can verify this with our previous method. So let's go ahead and do that just to make sure that we've done all of the work correctly, and that to kind of prove that this shortcut does work. Let's take our 1 and 7 over 11. We'll turn that 1 right here into 11 over 11. And we're going to add that to 7 over 11. Remember, and I can't stress this enough, this here is exactly the same thing as this. We're just rewriting it so it's easy to convert from one type of mathematical setup to another type of mathematical setup. So we add these, and we see that on the top, 11 plus 7 is 18. Now, when you're adding fractions, and maybe I should have specified this earlier, the denominators don't get added together. That's why it's so useful to write these like this. The denominator just gets carried over. And so in this particular problem, we just write 11. And again, hey, look at there, 18 over 11. So this has been converting mixed numbers to improper fractions. And this was part 2 of lesson 2-5 for Math 7. If you have any questions, you can go ahead and contact me at B Classroom. Otherwise, I hope that you, my students, have a wonderful day. Thanks for watching.